One of the two other important property of the Z transform, find the initial value, will be limit of the Z transform of the x z go to infinity. The initial value, that means x is 0, will be limit of the zx z go to infinity, and the final value of the signal will be limit of the 1 minus z minus 1 z transform of the x z go to 1. The initial value, if we see here, will be z go to infinity, and the final value of z go to 1. Now we get one example. They ask us to determine the x is 0, that means initial value of the signal about the zx of this. It's easy. You put the limit of this signal z go to infinity, and obviously if the z go to infinity, 1 divided by the z, that means because z minus 1, because 1 divided with infinity will be 1 divided by infinity will be 0. Here will be 0. 0 multiply any system will be 0. Another thing, they ask us the final value of the signals. The final value will be limit of the 1 minus z minus 1 z x z when the z go to 1. If you remember, you put the in the formula, and if you remember, this will be cancelled about this become 1, and 1 minus z1 will be x. When the z go to 1, 1 minus z minus 1, that means become 1 becomes 0. This total sentences will be 0. The answer will be 1. Now the comparison between the Laplace and the Z transform, we put some example. Here they put the Dirac K. Dirac K, they have an answer only this K equal to 0. The rest will be 0. How can I find the Z transform of the Dirac system? You put in the definition about the Z transform, will be definition of the become EK, my signal, Z minus KK from 0 to infinity. My signal here is a Dirac. If you know the Dirac, if you put the 0, only they have an answer, the rest will be 0. That means Dirac is 0, Z power 0, they have a value of the 1. That means Z transform of the Dirac Z will be 1. By the shifting theorem, Z Dirac and the Z becomes Z power n, because the rest will be multiplied by 1. How about the step? A step, that means less than the 0 become 0, bigger than the 0, the answer become 1. Okay, we put in the system, or in the definition about the Z transform, my signal is a step, and the definition is Z minus K. Here will be the K from the 0 to infinity, the step, the answer is 1. Okay, become 1 Z minus K. Here is a very important definition that you learned in the mathematics. Sum of the K from 0 to infinity, lambda power K, all the time will be 1 minus lambda. Lambda less than 1. This is the region convergence of this system. Keep in mind or memorize this one. Sum of the any signals K from the 0 to infinity, lambda K will be 1 minus lambda. Oh, here they have my system K from the 0 to infinity. Now this will be for me the lambda. Sum K is from 0 to infinity, lambda power K. The answer becomes 1 minus lambda. Here lambda for me is Z minus 1. The answer about the z transform of the step become 1, 1 minus z minus 1. Or if you denominator multiply by z will be z and z minus 1. This is the answer about the step. How about the yk become a power k bigger than 0 becomes 0, and the k less than 0 becomes 0. How can I find the z transform? For finding the z transform of the any signals, you put in the definition about the z transform. Definition z transform for me becomes sum k equal to 0 to infinity. My signals a power k z minus k. Okay. This one I can rearrange it, becomes sum k from the 0 to infinity a z minus 1, all of them power k. If you remember, now this one for me become lambda. The answer become 1 divided by 1 minus a lambda. My lambda is this. Or if you this one multiply by the z becomes z minus a. This is the answer about the z transform of these signals. And if you see here, they put the same thing here, become the lambda, and after that the answer become the 1 minus lambda, and they find the z minus a. And you remember, a power k z transform will be z minus a all the time. Now they find another signals e minus bt. How can I find the z transform of the signal? We put in the definition k equal to the 0 to infinity e minus bt z minus k. Okay, here they have some explanation. I will explain here. For the t, you must replace d by the kts. Here I replace by the kts. Then rearrange by the system about the k from the 0 to infinity e minus b ts z minus 1 power k. And if you remember, this will be lambda. The answer about here become 1 minus e minus b ts z minus 1. Or I can write the z minus e minus b ts. This is the z transform about these signals. In this slide, the same thing, they find the same result. Now the most important signals, we want to see what's happening for the ak cosinus theta k. What is the z transform about this signal? It's not difficult. We go ahead, just only we change the cosinus theta by e j k theta plus e minus j k theta divided by 2, and we put the one by one in the definition about z transform. First of all, I put this one, then I put this one, and I see that what's the result. First, ak ej theta. What is the z transform of the signals? ak ej k theta z minus k factors about the k. This become for me the lambda, and 1 minus lambda become my z transform. Denominator multiply by z, and you find the answer. Z minus e z minus e jt. Now we go for the second part of my signals. I put e minus j theta, and you find the answer 2. Here they put the e minus j theta, or here is a j theta. Here the same, but here should be e minus jk theta. Here become e minus jk theta. Here become minus, and here will be e minus j theta. Here will be minus. Okay. Here they forget, because one part you calculate this, another part e minus j theta. Here will be minus. And if you remember, the first one was the z divided by z minus a e j t. Another one will be this. Okay. Now you have two parts. One of them is a half of the zy1, the half of them is a zy2. This is the z transform. Here they made mistake. First answer will be half of the z minus a g theta. Another one become half of the z minus a e minus j theta. If you factorize and substitute the e j theta plus e minus j theta divided by 2 become cosinus theta, you will find the answer about the z transform of the cosinus a k cosinus theta k will be z minus a cosinus theta z2 minus 2z a cosinus theta plus a2. This is a z transform about these signals. Keep in mind, denominator will be z2 minus 2z a cosinus theta plus a2, and the numerator will be z minus a cosinus theta. The sinus will be similar, the same thing, only you should see the denominator will change. Denominator will become exactly the same as denominator about the cosinus theta. Okay. Now we go a little talk about the region